I'm Anil Kumar. Welcome to my series on sharing with you some popular and tricky questions to answer. We'll learn a strategy to solve this particular question, which is based on pattern rules for exponents. Find ones digit for each of the following. A. 532 to the power of 24 minus 243 to the power of 27. And B is 47 to the power of 48 minus 23 to the power of 23. You can always pause the video, answer the question, and then look into my suggestions. Now, whenever you get a question where you're only looking into ones digit, right? In that case, you don't have to bother about the big number. Just see what happens to 2 to the power of 24. In fact, you have to only consider the ones place for 2 to the power of 24. That is what it is. Now, all exponents, let me write down here. All exponents follow pattern. So that is important to understand. And so we need to just figure out what this pattern is. So we need to figure out pattern for 2 and 3 basically, right? So if I have 2 to the power of 1, it is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So see, ones place is 2, 4, 8, 16. And then 2 to the power of 5 is 32. So you see that 2 is repeated. Now, if I multiply by 2, this 2 becomes 4, then 8, and then 16, and then again it will be 2, right? So that means this pattern repeats, and the ones place will be 2, right? Ones place will be 2 for all powers which are 1 more than 4, correct? So we use the term mod 4, basically. So you can say mod 4, right? If you divide by 4 the exponents, then the remainder will tell you what power to match. 1, 2, 3, 4, right? 4 means 0, right? Remainder 0 means multiple of 4. So now 24 is basically a multiple of 4, right? You know, 24 divided by 4 is 6, remainder 0, correct? That means as far as 532 to the power of 24 is concerned, in ones place, what number will be there, right? Let's figure this out. So for 532, some big number, right? However, at ones place, it will be multiple of 4 gives you ones place as 6. So this number here will be 6. So we are now bothered about 6 minus this big number. We need to only figure out what is there on the ones place for 3 to the power of 27. Do you get the idea, right? So let's work with 3's. So for 3, we get 3 to the power of 1 as 3, 3 to the power of 2. 3 times 3 is 9, 3 to the power of 3 is 27, 3 to the power of 4 is 81. Now again, if I multiply 81 by 3, I get 3 as my ones place, correct? So 3 to the power of 5 is 3 and 24. You don't really have to remember this. So what you again see is that this also repeats, and the rule here again is mod 4. Is that okay? That is, when I divide by 4, then the remainder tells me what power, right? If you get 0, then it is to the power of 4. Now the exponent here is 27. So if I divide 27 by 4, what do I get? I get 4 times 6 is 24, and the remainder for me is 3. So remainder 3 means we're looking into this term, and the ones place is 7 for us. You get the idea, right? So when you divide 27 by 4, 4 times 6 is 24, 3 is the remainder. So it's kind of like this. Here we get 24, 25, 26, 27. So that power will be 7. So we get it. You get the idea, right? Now the question here is, what should be the ones place when I take away 7 from 6? Well, we'll have to borrow, right? So to take away, basically, now you should realize that we're not expecting a negative number, right? So what we do is we borrow, right? So when you borrow, it becomes 16, and from 16 we take away 7, we get 9 in the ones place. So for the very first one, 9 is in the ones place. So our answer is 9. Is that clear to you? Perfect. So that is how we are going to solve such questions. Now, you can apply the same strategy and find the solution for this one. So this time we are working with 7. Okay. So let's look into 7 pattern also. 7 to the power of 1 is 7. 7 to the power of 2. 7 times 2. 7 times 7 is 49. 9, right? Then 7 to the power of 3. When you multiply this by 7, 7 times 9 is 63. 6. 7 times 4 is 28, and then we get 34. But anyway, we are only interested in ones place, right? So 7 times 9 is 63, 6 there. 7 times 4, 24, 28, and 6 is 34. Now, if I do 7 times 4, again multiplying 3 by 7 gives me 21, right? So 1, 2 goes there. 7 times 4, 28, 0, right? And 3 goes there. 7 times 3 is 21, and 3, 241, right? Something like this. So what I'm trying to tell you here is that ones place is 7931. So if I do 7 times 5, I do get 7 here, right? So it repeats. So here also, rule of mod 4 is applicable. Perfect. So we can figure out 48, when I divide by 4, I get no remainder, right? It's a multiple, 24 remainder 0. That means 7 to the power of 4 works for us, right? So when you multiply 7, 7, 7, 7, 4, you get 1 at the end. So here the remainder is 0. So fourth term, we have to see what is there in the ones place. Well, clearly, ones place give you 1, right? So here we get 1 here in the ones place, the rest of the number on the other side. Minus. Now 3 to the power of 23. As far as 3 to the power of 23 is concerned, let's divide 23 by 4. So we get what? 4 times 5 is 20, remainder is 3. So we have to look for 3 again, which is 7. Okay. Now in this case, we have to take away 7 from 1. You need to borrow, correct? So when you borrow, you can take away from 11, 7, and what you get is 4. So this time, the ones place or ones digit will be 7 when you do that algebra, right? Taking away the numbers from the other numbers. Is that clear to you? Perfect. So that is how we are going to solve this particular question. So I hope the concept is absolutely clear. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. You could practice with similar questions, since this is indeed a very popular question. Thanks for your time and all the best.